This is revision for energy stores and transfers, which is part of topic 7i. This covers 2 lessons in that topic. So in this lesson, we're going to be looking at being able to know that energy can be stored in different ways, understand how energy can be transferred between those different stores, and then be able to identify stores and transfers and then describe them using scientific language. So there are 6 energy stores that you need to know about. They are chemical energy store, which is stored in food, fuel, and batteries. There's the kinetic energy store, which is stored in moving objects. Anytime we have an object moving, there is a store of kinetic energy. There is thermal energy, which is stored in hot objects. So anything that is hot. Now, hot just means any object. Okay, so even us, we have a store of thermal energy. Even an ice cube has a store of thermal energy, just less than a hotter object has. So just be careful with that. There's elastic potential energy, sometimes referred to as strain energy, which is stored in stretched, squashed, or twisted objects. There's gravitational potential energy, which is stored in objects in a gravitational field. Okay, so imagine holding an apple up. It has a store of gravitational potential energy. And finally, there is nuclear energy store, also known as atomic energy, and that is stored inside atoms. Okay, but you can't get that transferred by burning it. Okay, we think of nuclear, so like a nuclear bomb, you get stores of nuclear energy being transferred. And remember, the unit that we use for energy is joules, which is a capital J. So, if you'd like to have a quick go at seeing if you can identify any of these, the stores represented in these pictures, okay, there might just be one store, there could be multiple, so just think of many as you can. Okay, so let's go through it. So in the first one, we're going to have a thermal store. Okay, remember I said humans, we have temperature, therefore we have a thermal energy store. We also have chemical energy store, okay, so like the glucose that we store in our body. And we have a nuclear energy store because obviously we're made up of atoms. The main one for the elastic band ball is elastic potential store, okay, because remember squashed, stretched, or twisted objects. In the case of this helicopter, we've got gravitational potential because it's lifted itself up in a gravitational field. It's got kinetic because those blades are turning around. It has chemical from the fuel that it's using to produce that rotation of the blades. And there's also thermal because that engine's going to be getting hot. For the battery, we have a chemical energy store. For the candle, we have chemical and also thermal. Okay, so the chemical is going to be the elements that are being burnt here to produce this flame, and the thermal energy store from the flame. And finally, here in the power plant, there is a nuclear energy store from all those elements being used to, in nuclear fission, chemical, and also thermal. So now that we've looked at the different energy stores, there's an important law in physics that you need to know about, and that is known as the conservation of energy. That states that energy cannot be created or destroyed, it can only be transferred from one store to another. Okay? You might think this is similar to the conservation of mass, which is true. So you would have also looked at conservation of mass, which says the total mass before and the total mass after has to be the same. This essentially says the same thing. The total energy in all stores at the start must equal the total energy in all of the stores at the end. So we've got energy stores. We know that the total energy before and after in all the stores must be the same. So now we need to look at how we can transfer that energy from one store to another. Those transfers are either heating, by light, by sound, by electricity, or by forces. Okay, those are the 5 ways in which energy can be transferred. So if we have a quick look and think about how we could transfer energy in each of these scenarios, okay, so think back to obviously heating, light, sound, electricity, and forces. So if we go through these, in the car, there's obviously light, sound, electricity, heating, and forces. So it has all 5, okay? So I think the main one being forces, okay? So there can be forces applied by the engine, which make the wheels turn, which then makes the car move. You've got lights, Obviously, you've got the sound of the engine, there's electrical components in the car, and obviously the engine gets hot. A radiator, the main transfer there is heating. In a light bulb, there is light, electricity, and also heating. So remember, especially filament bulbs are very inefficient and they get hot. So they are also transferring energy by heating. From a TV, there is light, sound, and electricity being the transfers. From a pair of headphones, sound and electricity. And from these pylons here, just electricity. There would also be a small amount of heating in that example as well. So we've looked at stores, how we can store energy. We've looked at how we can transfer that energy from one store to another. And we've also looked at the fact that all the energy at the start must equal the energy at the end in all of the stores, okay? So you can't create energy, you can't destroy energy. And so finally, the one thing we can look at now is we can represent all of this by using flowcharts. So for example here, if we look at this one for this boy walking, he initially has a chemical energy store because of all the glucose that he's got stored in his body from eating food. That can be transferred to the kinetic energy store because he's moving by forces. Okay, so there are forces being applied that allow him to start walking. So we're getting a chemical energy store being transferred by forces to the kinetic energy store. Okay, the starting energy store is the one that is going to get smaller. Okay, so we always put that on the left. The final energy store is the one that is going to get bigger, and we always put that on the right. And then we put an arrow, and on top of that arrow, we put the energy transfer that is taking place. So in this case, it's being transferred by forces. So have a go if you can at this one. So we've got a girl who is swinging downwards from high up in the air on a swing. So remember, she's starting from a high up place, and she's going down. So think about what's going to be happening. So you could probably already guess that she's going to start speeding up, okay? If you've been on a swing, as you go up high, you slow down, and you reach your highest point, and then you start coming back down again, and you get faster, okay? So there we've got the bare bones idea. We now just need to convert that into a scientific version using the language of stores and transfers. So firstly, we need to identify what is the energy store that is increasing, and we'll put that on the right. We then need to identify the energy store that is decreasing, and we'll put that on the left. And then we need to identify the energy transfer process. So see if you can have a go at this before we go through it. So starting off, we know that she's starting from high up in the air. So she's going to, be gaining kinetic energy as she goes down, okay? And like I said, she's starting off high up in the air, so she's going to have a store of gravitational potential energy. And how's that being transferred? Well, if it's a gravity, there's going to be forces. So that's being transferred by forces. So you can have a go at this one. We've got a Bunsen burner being used to heat some water. So remember, identify what's decreasing, identify what's increasing, and how that energy is being transferred. So in this example, the store that is increasing is the thermal energy store of the water. Okay, it's getting hotter. The store that is decreasing is the chemical energy store from the gas being burnt by the Bunsen burner, and that is being transferred by heating. We're now going to look at a slightly more difficult situation where you have more than one transfer. So very often in physics, you're not just going to have one transfer, you're going to have multiple taking place. And as you go further down through your career at school, you'll also then start looking at what we refer to as useful and not useful transfers. But for now, we're just going to look at the transfers. So here we have a situation of somebody rubbing their hands together, and there are two energy transfers taking place. So we've probably all done this at some point. You rub your hands together, you might be doing it when it's cold. So we do it to warm our hands up. So we know there's going to be some thermal energy store increasing there. Also, we're moving our hands. So there's going to be an increase in kinetic energy store. So those are the two stores that we know need to go on the right. So what store is decreasing at the start? Well, we know to move our hands, we need to move our muscles. And for our muscles to move, they need to use the food that we've stored in our body from eating. So there's going to be the chemical energy store decreasing. So we've got our kinetic energy and thermal energy stores. And we're starting with a store of chemical energy. So how do those two end up being transferred? Well, from chemical to kinetic, we're having a transfer by forces. Like I said, our muscles are moving and producing a force. And then from chemical to thermal, we've got transfer by heating. And just to chuck this in here, going back to our conservation of energy, if I had 6 joules of energy at the start, for example, I had 4 joules of kinetic energy at the end, because I have to have the same on the left as I do the right, I would have to have had 2 joules of thermal energy being transferred. So that is one way we can use the conservation of energy in a mathematical way. So to round up, we have looked at how energy can be stored in our different stores. So for example, chemical, nuclear, kinetic, gravitational potential, elastic potential. We now hopefully understand how energy can be transferred between those different stores via forces, heating, light, sound, and electricity, and also able to identify stores and transfers when we're given an example, be able to put them into a flowchart format, and also use correct language to describe them scientifically. So hopefully that's helped. If you need to go back through this video, do so. Thank you.